Okay, today we're going to start Chapter 6, the diseases and conditions of the cardiovascular system. So, in your book, starting at page 112 is where we're going to begin, and I'm going to go ahead and look on the PowerPoint. We're going to start just with a rough overview of the organs of the cardiovascular system. We have blood vessels, of course, and in the blood vessels we have arteries, veins, and capillaries, and those are the blood vessels that feed the heart and the other parts of your body. So let's look on page 112. There's 3 layers of the heart. We have the pericardium, which is the outside sac that surrounds it. We have the myocardium, which is the heart muscle itself. And then we have the endocardium, which is what lines the inside of the heart, or the heart chambers. So those are your 3 layers of the heart that you need to know. Now let's go on and talk about valves. The valves we have are the mitral valve and the tricuspid valve. The mitral valve, you may have heard of a disease called, or a condition called mitral valve prolapse, but the mitral valve is between the left atrium and the left ventricle, and then the tricuspid valve is between the right atrium and the right ventricle. Okay, so what it is these valves have cusp on it, like a doorway, like flaps that flap open and shut. And what they do is the valves, when blood is pumped in, it goes through this valve, and the valve decides when to release it. And because basically if you didn't have like a doorway there, then you would just get continuous blood, and it needs to go into the valve, and then the cusp will hold it and then release it. So that's what its job is to do. Looking on slide 11, the function of the cardiovascular system is to maintain the distribution of blood throughout the body. Let's see, we have 2 parts. We have a pulmonary circulation, and then we have the systemic circulation. So let's look at the pulmonary circulation. Pulmonary circulation happens between the heart and the lungs, and it transports deoxygenated blood to the lungs to get oxygen, and then it pumps back to the heart. Now the systemic circulation carries oxygenated blood away from the heart to your tissues and your cells, and then after that it comes back to the heart, and then all the cells in the body and the tissues in the body receive blood and oxygen. So those are the 2 parts of the cardiovascular system. Now let's look at the heart in itself. The heart is a muscle, and it's a pump. So as it pumps blood in, out from the top, in from the bottom. It's made up of cardiac muscle fibers called Purkinje fibers. And it has 4 chambers. We have the right atrium, the left atrium, the right ventricle, and the left ventricle. Okay? And these, let's see, if you look at figure 6.3, that shows you a really good, a pretty good illustration of it. The average beats of the heart is 60 to 100 beats a minute, and each time that happens, blood is being ejected from the heart through the body to the blood vessels. So that's when you feel the pulse, because you're feeling blood rushing through. So that's what the pulse is. So anywhere, just remember 60 to 100 beats per minute. The heart is located in the middle of the body, and a lot of people, when we put our hand over our heart for the Pledge of Allegiance, but the heart is actually right in here in the center, in the mediastinum, or the mediastinum, everybody says it a little different, which is the center of the chest cavity. It's about the size of a fist, and it's shaped like an upside down pear. So it's going to be bigger up here, and then it's going to go thinner down in the middle. The tip of the heart is called the apex of the heart, and that's where we will count an apical pulse, which is the most accurate way to capture a pulse, is the apex of the heart. It's also the hardest place to hear a heartbeat. And then we have the sternum, which protects the heart, the sternum in the rib cage, and it's located directly in front of the heart, and that's that big bone that goes down the center of your chest. Okay, so we already talked about the heart layers, so and I already told you about the heart chambers. It's dividing into 2 atrium and 2 ventricles. right and left atrium, right and left ventricles. Um, the walls that are in between, separate the atrium and ventricles from each other, are called septums. So the atria's function is to receive, get tongue-tied. The atrium's function is to receive blood, and then the ventricles are the pumping mechanisms, and they pump out blood. Let's see, heart valves, we talked about the valves. We talked about the tricuspid and pulmonary, but you also have the mitral. No, we talked about the tricuspid and mitral, but you also have the pulmonary and the aortic valve too. So as I told you, these act as doorways to control the direction of blood flow. Now, some people have a valve defect where you may have like a regurgitation of blood flow, so there can be some things wrong with that, which we'll talk about later in the book. Let's see. The tricuspid valve is also called the atrioventricular valve, or the AV valve, and it controls the opening between the right atrium and the right ventricle. Let's see. The pulmonary valve is also called the semilunar valve. Semi meaning half, lunar meaning moon, so it's like a crescent moon shape, located between the right ventricle and the pulmonary artery, and it allows blood flow from the right ventricle into the pulmonary artery. Then we have the mitral valve, also called the bicuspid valve, because bi meaning two, so it has two cusps on it. Blood flows through the AV valve to the left ventricle, and it can't go back into the left atrium, basically. Then we have the aortic valve. Blood leaves the left ventricle through the semilunar valve located between the left ventricle and the aorta. So that's the aortic valve. Let's talk about blood flow through the heart, because, and you may have had to memorize this before if you took any kind of anatomy. But deoxygenated blood from all the tissues except the lungs enters the right atrium from two large veins called the superior vena cava and the inferior vena cava. So after that happens, the right atrium contracts and blood flows through the tricuspid valve into the right ventricle. The right ventricle will contract and blood is pumped through the pulmonary valve into the pulmonary artery, and that carries it to the lungs. Pulmonary meaning lungs, if you can remember that. Then the left atrium receives the blood that's been oxygenated by the lungs. After it leaves the lungs, it's going to go to the left atrium. So this blood enters the relaxed left atrium from the four pulmonary veins, and the left atrium contracts and blood flows through the mitral valve into the left ventricle. Now at that time, the left ventricle is going to contract, and blood is going to be pumped through the aortic valve and into the aorta, which is the largest artery in the body. And then the aorta carries the blood all the way back, all the way down to the different parts of the body, except the lungs. So if you look at slide 35, there's a great animation of blood flow there that is really helpful and useful to actually see it. Let's see. Let's talk about heart chambers. We need to talk about systolic and diastolic on page 113. The relaxation phase of the heart is called diastole or diastole, or diastolic when we're talking about blood pressure, and then when the heart is contracting, it's called systole. Okay, so when you take a blood pressure, you're going to have systolic over diastolic, meaning systolic is when the contraction phase, and then the diastolic, it should be the relaxation phase. So that's why they say when the bottom number is most important, because if the heart's not relaxing, then that is not good. It can cause major heart damage. The conduction system of the heart. With the autonomic nervous system controls our heart rate. We have no voluntary control. It's all involuntary muscles that do that. We have special tissues that can conduct the electrical impulses of the heart, and they start with the SA node. The SA node is a sinoatrial node, and it's also called the pacemaker of the heart. Then we have the AV node, or the atrioventricular node, and this is going to transfer stimulation to the bundle of His. Okay, so the bundle of His is the electrical signal that travels to the bundle branches. Okay, then after that it's going to go to the Purkinje fibers. So again, the four parts of the electric system of the heart is the SA node, the AV node, the bundle of His, the five things, the bundle branches, and the Purkinje fibers. So that makes up the electric system of the heart. Okay, now let's get into the types of blood vessels. We're going to look at on page 115. We have arteries, veins, and capillaries. Arteries are your largest veins, and they're thick-walled and they carry blood away from the heart. Now veins carry blood back to the heart, and then capillaries are those really tiny capillaries, and they connect units between the arteries and the veins, and they carry oxygen-rich blood from the arteries to the cells. So this is what we have, like right underneath the skin, everywhere in our body is capillaries, tons of capillaries. Blood pressure, we already talked about that, but the normal blood pressure is 120/80. 120 is systolic, 80 is diastolic. So make sure you remember that. Let's see. Okay, let's go on to slide 57, control of the heart and the influence of the autonomic nervous system. The heart can actually pump without nerve stimulation, so it can do that. The sinoatrial node is the pacemaker of the heart, like I said, and it will initiate the heartbeat. That's why it's called the pacemaker of the heart. The impulse for, let's look at the autonomic influence. I'm sorry, I know I'm skipping around. Let's look at the difference between the parasympathetic and the sympathetic. The parasympathetic is the vagus nerve, or you may have heard something called like a vasovagal response. This is what this is talking about. A vagus nerve secretes a substance called acetylcholine, which will slow the heart rate. Okay, so if somebody is having some kind of trauma going on and the heart rate is going boom, 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 real fast, the emergency room may give this acetylcholine to slow the heart rate down. And the sympathetic nervous system stimulates the release of epinephrine into the bloodstream. And epinephrine, of course, will speed up the heart. So when somebody is coding and they start flatlining, the medical professionals will give epinephrine to try to increase the heart rate. Let's see. Let's go on. Let's go on and talk about the diagnostic procedures. On page 117, we have auscultation. You can do an ECG, an echocardiography, and a color Doppler echocardiography. So auscultation is when you just listen to the heart sounds with a stethoscope. ECG is when they put the leads around your chest and on your extremities, and they'll look at the electrical impulses of the heart. They'll look at the heart waves. An echocardiogram is when they do kind of like an ultrasound, and you'll be able to see the heart and how it's working. And the color Doppler is pretty much the same thing, except it's in color and you can see blood flow. So those are some of the common tests that you can do. We also have cardiac catheterization that you can do. Now this is pretty common. This is when an artery is blocked, and it's usually a coronary artery that's blocked. And we'll do like a balloon angioplasty, where they'll feed a catheter into the vein, and then they'll inflate a balloon to knock the plaque out of the veins. Now that can be dangerous too, because the plaque can go to places it's not supposed to go and cause an embolism, which could be very dangerous. Let's see, exercise tolerance test is another thing that we can do just to see how the heart is working. And then of course we can do x-rays of the heart and all the vessels with an arteriogram. Alright, we're going to stop there, right there. That's going to be the first part, and then the next part we'll pick up with hyperlipidemia.